Hello my dear students. So in my previous class I started explaining about errors in quantitative analysis, right? So I defined what is meant by error. So error is defined as the numerical difference between the observed or measured value, which is represented as x naught, and the expected or true value, which is represented as xe. Okay, and with this definition we also understood how do we calculate the absolute error and what is meant by relative error, and how we are going to measure relative error in terms of using mathematical expressions or equations. And further, the relative error of measurement in terms of percentage also we can calculate. So how we are going to calculate the relative error in terms of percentage, and the relative error, it can also be represented by parts per thousand. Okay, so this is where we stopped in our previous class. Okay, so related to error and what are the different types of error, or how do we measure the error in terms of percentage, in terms of parts per thousand. So all these things we understood in my previous class, and in this session, so let us understand how we are going to classify the errors. Okay, so as I said in my previous class, errors are mainly classified as two types. One is determinate errors and another one is indeterminate errors. Okay, so now we will see in deep what is meant by a determinate error. So these errors are determinable. That means we can find out the errors and we can minimize the percentage of errors. So such type of errors are called as determinate errors. So these determinate errors are further classified into three types. That is, first one is instrumental error, and second is methodic error, and the third one is operative error. Okay, so what is meant by instrumental error? So instrumental error means so these are the errors which are introduced by the instrument. Okay, so while measuring the readings, we will make some mistakes that will be shown by the instrument. So these errors are introduced into the measured value by the instrument which we are going to use. The instrumental error may be introduced into the measured value because of the following reasons. So what are those reasons? Let us see. So the first one is use of defective instrument. For example, so when a 20 cm cube pipette which actually measures 20.1 cm cube is used, an error is introduced in the volumetric analysis. Okay, so this is one example. Yes, of course, we cannot trust on the instruments what we are going to use. So say for example, in the pipette, in one pipette may exactly measure 20 ml, and another the same 20 ml pipette itself, but there might be the manufacturer defect where we can measure 20.1 ml or sometimes 19.9 ml or 8 ml, like this. So all these changes or the manufacture errors, so they introduce error. So such a type of error is called as instrumental error. And next is the environmental factors. Suppose for example, if we take if a pipette calibrated at 20 degrees centigrade is used at 30 degrees centigrade, definitely an error will introduce. Okay, so an error will be introduced in the measured volume. And next type of reason is how the instrumental errors are going to form is power supply. It is not in our hand, right? Power supply is not in our hand. So for this reason, fluctuations in voltage may introduce an instrumental error. So the sources of instrumental errors must always be remembered whenever an instrument is used. Okay, so this is all about instrumental error. And the next type is a methodic error. For example, so in volumetric analysis, the use of an improper indicator leads to wrong results. Okay, so this is method. Method means which procedure we are using, in which basis we are examining the experiment. So that completely depends upon the experimental methods. Okay, so these methodic errors are introduced by adopting defective means some wrong wrong or undesired experimental methods if we employ, so then methodic errors will be introduced. And another example is in the gravimetric estimation of lead as lead chromate. The method of precipitation of lead chromate may involve co-precipitation of impurities. Okay, and the third example is a lack of proper understanding of the theoretical background of the experiment may also lead to the methodic error. Generally, it is very difficult to detect the methodic error, and hence it is most serious among the three types of determinate errors. Okay, so methodic error is it is quite difficult to rectify it. That is because completely, suppose if the method itself is wrong, so then we have to check each and every step of the reaction or the experimental procedure. So it is very difficult for us to identify. See, suppose if instrument is defective, then we can sort it out, or if operative error is something problem is there, then also we can sort it out. But if the method or the experimental procedure, if that itself is wrong, so it is very difficult to identify it and also rectify it. Okay, so that is why generally it is very difficult to detect the methodic error, and hence it is most serious among the three types of determinate errors. Okay, and the third type of determinate error is operative errors. So these are the personal errors. Operative means the errors which are formed during the operation. Who will do the operation? We. Okay, analyst. So I am performing a volumetric analysis, or I am operating a system, say for example some spectrophotometric system instrument I am operating. So even when I operate it, even though if I am very much experienced in handling that, sometimes personal errors also takes place. Okay, so what are the reasons? We will see that one by one. So these errors, that is operative errors, are introduced because of variation of personal judgment. Okay, so say for example I read a burette. Okay, so I read a burette that 40.5 ml. I will be reading it from lower meniscus or higher meniscus, and the same reading will be read out by some other person, and his perspective will be different. So in that manner, so 0.1 ml of difference definitely we will get. Okay, so that is say for example due to color blindness. So okay, I said due to the perspective of lower meniscus and higher meniscus, but in our book it is there, that is the example is due to the color blindness, a person may arrive at wrong results in a colorimetric or volumetric analysis. Yeah, of course, this also can happen. And the next type or next way how the operative errors could be introduced means so using incorrect mathematical equation and committing arithmetic mistakes, misplacing numbers and decimals. Yes, sometimes while writing it down, so we may misplace the numbers and decimals in recording data, reading a scale wrongly, reversing sign, and using a wrong scale. Okay, so all these things will introduce operative errors. And next is carelessness of operators or inadequate instruction to the operator. Yeah, sometimes even if I am more experienced, means definitely I will have, this is very simple, I can do it, or I can read it out. So in that carelessness, so we may introduce operative errors. Okay, and also inadequate instructions. That means if that person who is handling the instrument or who is performing that experiment is a new one to that experiment, if he don't have proper instructions how to operate that instrument, definitely operative errors will be introduced. And the personal error may also arise due to bias. Okay, it is a human tendency to estimate reading in a direction that improves the accuracy and precision of the results. Okay, so these are different ways how operative error can be introduced. Okay, next, moving on to the next slide, how to minimize these determinate errors. So the following measures may minimize the error and improve the accuracy. What are those? So the first one is every instrument used in the analysis must be properly checked and calibrated. blanks should be used along with the test sample wherever possible. Okay, using blank is very very important, so that so we will adjust it, we will calibrate it to the 100%, so that minimization of errors will be there. So wherever it is possible, so along with the test sample, it is good to use blanks. Okay, and the next is proper conditions at which an instrument works are to be maintained properly. And next, a particular measurement should be repeatedly made under identical conditions and its constancy checked. All possible personal errors must be predicted and eliminated in each measurement. Okay, and next is personal errors or gross mistakes are avoided. Right, how we are going to avoid it? So personal errors or gross mistakes like making arithmetic mistakes, reading a scale wrongly, right, and transposition of numbers in recording data, reversing sign as I said earlier, using wrong scales and applying the wrong equation must be strictly avoided, and the computing equipment must be checked for its correctness, and the reading which has to be taken must be reread repeatedly and then recorded. Okay, so once in a while we should not come to the conclusion, we should reread it repeatedly and then we have to record it. And an experiment for obtaining data should be performed when the analyst is tired, not received complete training. Okay, should not be performed. Okay, an experiment for obtaining data should not be performed when the analyst is tired. Okay, so when he is tired, then his mind will be in that way that let me finish it earlier, I am tired, I want to take rest. In that hurry, so definitely he will make determinate errors. So to avoid determinate errors, definitely the experiment should not be performed when the analyst is tired or not received complete training. Okay, and next is a standard method must be used, and experimental list must experimentalist means the one who is going to perform the experiment, he is called as experimentalist, must understand theoretical background of the method before performing analysis. Okay, so these are the 10 different measures which we can take to minimize the error and to improve the accuracy. Okay, and the second type of error is indeterminate errors. So these are the errors which cannot be determined or predicted. So these errors are also called as random errors or accidental errors. For example, when a student determining boiling point of an organic liquid as 182.0, 182.1, 182.3, 182.2, 182.1. Okay, so like this, so although he used the same apparatus, there is an error in his measurements. Okay, a slight error is there. So this error is indeterminate error which cannot be determined or predicted. Okay, so which cannot be determined or predicted. So this error follows random distribution. Indeterminate errors arise from uncertainties in measurements that are unknown and beyond the control of the experimentalist. So the reasons for the indeterminate errors cannot be predicted. Okay, when we cannot predict the reasons, definitely we cannot rectify it or overcome these indeterminate errors. So when pipetting out a liquid, the position at which the pipette is held, the angle of holding the pipette, and the speed of draining, etc., may introduce indeterminate error in the volume of liquid pipetted out. Okay, so see, so this is why indeterminate errors are not which cannot be determined or predicted. So that is why we should take care in the beginning itself to avoid these indeterminate errors. Okay, next is what is meant by mean, median and range. So the measured scientific data are subjected to certain mathematical and statistical tests before accepting and reporting. Okay, so this you all have come across, that is while doing the titrations also. So not only one trial is allowed. So you have to perform, you have to take 2-3 trials, and concordant value has to be reported. Okay, so once in a while if you get one reading, so that is not final. So that is why, so mean, median and range is very very important, which is measured by scientific data, which are subjected to certain mathematical and statistical tests before accepting and reporting the values. So some of important terms used are, first one is mean. So now let us understand what is mean and how do we calculate mean. The mean, or it is also called as average value. Okay, so you all know how to take a average value, or you have already come across in your life. So the mean is obtained by dividing the sum of set of replicate measurements by the number of individual determinations. Okay, so if trial C1, C2, C3, it goes on up to Cn are replicate measurements, and n is the number of determinations, that is number of trials you have performed, then mean is given by, mean is equals to, so we have to sum up all the replicate measurements, that is C1 plus C2 plus C3 plus it goes on up to Cn divided by n. N is the number of determinations you have performed. Okay, so in this way we are going to calculate mean. Let us take an example so that it will be more clear for us. So the example says that in a volumetric analysis, if 5 iterations are done, yeah, that this is what I told. Suppose if you have performed 5 iterations, all the different titer values are like it will be 10.0 cm cube, 10.1 cm cube, 10.3 cm cube, 9.9 cm cube and 10.2 cm cube. Then mean or average titer value is, mean is equals to sum up all the titer values divided by the number of titrations you have performed, 5 titrations divided by 5, which is equals to 10.1 cm cube. So this is the mean value. And next is median. So median is a value about which all other values in a set are equally distributed. Half of the values are greater and the other half are smaller numerically compared to the median. Okay, so this is what is called as median. So median is nothing but it is a value about which all other values in a set are equally distributed. So let us take one example and we'll understand it. So example is, so the density of water is determined at a particular temperature and 5 different values obtained by replicate measurements. What are those 5 different values? So the values are 1.01, 1.03, 1.04, 1.02 and 1.05. Then the median value is 1.03. Okay, so why 1.03 is so when a set of data has an even number of values, then median is the average of the middle pair. Okay, so here average of the middle pair is 1.03. okay. Next, suppose 4 different titer values are obtained, that is one is 10.1, 9.9, 10.2, 10.3 centimeter cube. Then the median is average of 0.1 and 10.1 and 10.2. Average of 10.1 and 10.2 means it is 10.15 cm cube. Okay, so this is how we are going to understand median and we'll calculate the median. Next is a range. What is meant by range? The difference between the maximum value and the minimum value of the set is called as range. Maximum matte minimum value difference. What is the difference between maximum value and minimum value is known as range. Okay. The value of range is the measure of precision of the values. Okay. So value of range is the measure of precision of the values. Okay. Next is accuracy. What is meant by accuracy? This is very important, accuracy. So the accuracy of the measured value may be defined as nearness of measured value and expected value or true value. Okay, so it is given in terms of error. Higher the error, lower the accuracy of the measured value. The accuracy may be given in terms of absolute error or relative error. Let us take one example so that it will be more clear for us. Example 1. So if a student obtains a value 1.70 into 10 raised to minus 5 for the dissociation constant of acetic acid at 298 Kelvin, and the expected or true value is 1.75 into 10 raised to minus 5, then the absolute error is given by, how we are going to calculate the absolute error? Just like how we saw in my previous class, absolute error is calculated as so ER is equals to x naught minus XE, right? X naught minus XE. So XE is the observed value, x naught is the observed value, and XE is the expected value. Okay, so observed is 1.70, expected is 1.75 into 10 raised to minus 5. So this is minus 0.05 into 10 raised to minus 5. So now relative error in terms of percentage. I am calculating relative error in terms of percentage. So then ER is equals to XE minus X naught divided by XE into 10 into 100. So substitute the value XE. So this is the expected value 1.75. So the difference is absolute error. The difference of observed value and expected value is minus 0.05. So while calculating the error, we can neglect the negative signs. Okay, so that is why I have taken just 0.05 into 10 raised to minus 5. So while if we calculate this, so we are going to get 2.85 percentage. That means so the error is 2.85 percentage. Okay, so similarly the second example, so the two students A and B reported the mass of barium sulfate obtained by gravimetric methods, that is 0.2934 grams and 0.2893 grams respectively. The expected value is 0.2894 grams. So the value 0.2893 gram reported by B is more near and it is more accurate. So the value 0.2934 gram is not so near to 0.2894 grams. Okay, so that is why that value is less accurate. Okay, so next is what is meant by precision. So precision is defined as the agreement between the numerical values of two or more measurements of the same quantity. Okay, so here the measurement is made of the same quantity, and it is the agreement between the numerical value of two or more measurements. So we have to say which value is correct. Precision is the measure of closeness between the different values in a set of results measured under identical conditions. So the datum is said to be precise only when it is reproducible. So this is the condition. Okay, so a precise value need not to be accurate. Okay, so now we'll take one example. That example says that when the weight of a weighing bottle is found to be 10.2284 grams, when every time it is weighed, the value of weight should be 10.2284 grams in order to say the value is precise. Okay, so this is how we will say, means in how many times of repeated experiments we are conducting, the value should be same. Okay, so then we say that the value is precise. So precision of data can be expressed by following methods. So what are those following methods? So the first one is mean deviation, or it is also called as absolute method. So in absolute method, the precision is expressed in terms of deviation from the mean. So we are going to use x naught minus x bar without considering sign. Okay, so here this should be x naught minus x bar. So it has gone here. Okay, so please observe it and read it as x naught minus x bar. So this line should be here. So see, here also error has been occurred. So this is I think this will be considered as operative error. So this bar should be here, x bar, x naught minus x bar without considering the sign. Okay, for example, the percentage of carbon in an organic compound was determined in replicate. the data are as follows. Okay, so here 5 different sample of an organic compound has been taken, and they have been analyzed for to find out the percentage of carbon, and these are the values, the percentage of carbon, and this is the deviation from mean. Deviation from mean means, so what is the difference? So we'll see how we are going to calculate it. So mean is mean means how we are going to calculate mean. So we have to sum up all the values here, the percentage of carbon. So all the values has to be summed up, and it is divided by 5, and that will give 38.26, right? So 38.26. And mean deviation means, so this is mean deviation. So mean deviation is given here. Suppose if it is not given means, then we have to calculate it. That we will see in my next class how we will do it. So in this way mean deviation is found out, and here what we have to observe is the mean deviation or average deviation is very small. So if we observe this 0.092 means here the mean deviation is very small, hence the values are precise. And one thing what we have to note down here is smaller the mean deviation, greater is the precision of the values. Okay, so this is one statement which we can make based on mean deviation or absolute method. Okay, so I am going to stop it here. So we will continue in my next class with relative deviation, what is meant by relative deviation, and how do we calculate or understand the range in terms of precision. Okay, so all these are used for the precision of a data, which can be expressed in these forms or in these methods. That is, one is mean deviation, relative deviation, what is meant by relative deviation, what is meant by range, and next is the standard deviation, which is very important, standard deviation, and also coefficient of variance. So all these are mathematical set of statistical data which are used to understand precision. Okay, so in my next class we will continue with the rest of the things. So thank you, dear students.